And welcome to the last day of conference's lightning talks. How's it going till now? Perfect, thank you. That sounds like a good noise. And we have our first speaker, Emma Cooke, talking about the best and worst of the weird and wonderful world of Olympics mascots. Please have a huge round of applause for her, and let's see.
I like having intense feelings about weird things, so this is my entirely subjective, entirely unofficial rankings of some of the best and worst Olympic mascots over the years. Fifth worst for me is Izzy. This was the first mascot entirely computer generated, and the computer spat out this random blue blob. It has the nickname What's It because people looked at it and went, what is it? Fourth worst for me is this pair. So I'm not on board with human figures as mascots. They should be fun creatures, not creepy Viking children. Next up is another creepy pair. This is apparently a snowball and an ice cube, fundamental components of a successful Winter Games. The promos had them falling in love. Fun fact, this was the winning design of a 3-year-long international contest, which received over 200 proposals. But for me, they remind me of teeth. They remind me of the dentist, of toothpaste. I'm not on board with it. Second worst, shuz. This is the first unofficial mascot of the games, and the only thing I can tell you about this guy is that he was designed in just one night. You can tell. But the worst of the worst for me is Wenlock. This one-eyed, creepy steel nightmare. Apparently, the eye is a lens that was supposed to be recording everything it saw, which is a bit too 1984 for 2012 for my liking, so take a bow, London. Let's move on to the good stuff. Fifth best, Waldy. Just a very good boy, enough said. Fourth best for me is Vuchko. I really like this kind of Pink Panther-esque design. He's mischievous, he's menacing, but in a fun way, and let's be real, he's rocking that scarf. Third best then, Misha. This adorable Russian bear. It's cute, it's cuddly, but also let's not pass over that booty pop. Looks like he's gonna start twerking. He's cheeky and I'm here for it. Second best for me is Kwachi and Miga. Leave it to the Canadians to create the friendliest and most welcoming of the Olympic mascots. I mean, they're waving at you straight off the bat. I would hang with these guys. I mean, I want to spend a day with them. You know, it's the classic little guy, big guy pairing that we all know and love. But the best of the best for me is, might be controversial, Freesh. So shout out to my partner on this one who went to the Paris Games and on a whim brought back this silly little red plushie as a souvenir, and I just think it's adorable. For some reason, it makes me laugh, and now it comes on all our travels and makes great photo ops. If you too have strong feelings about really specific things, please talk to me. Thank you.
Thanks a lot for that. The next talk is from Benoit Godard, yet another DI container. A round of applause for him.
Thank you. So hello, everyone. I'm very sorry because this is not going to be as funny as the previous talk, but first thing first, can we talk a bit about our Lord and Savior, dependency injection? Thank you very much. In any case, you don't have the choice because this is my talk and I'm sorry. So let me introduce you a library, small Python library I've created, which is named Handless, and which is just yet another dependency injection container. So who I am? I'm a lead software engineer at a Luxembourgish company named Delaware, and I've got a bit more than 10 years of experience in development and 6 in Python. And as you can see, I've got a pretty big family beside my daughter and my wife, which is watching this video as well. So the pain. Have you already felt that pain looking at that kind of code? I hope so, and I can imagine the pain you felt at that time. So you can imagine that kind of code is pretty hard to test, almost impossible to mock or swap without monkey patching, and it's strongly coupled. So let's meet the dependency injection. Instead of creating your dependencies on the fly, on your constructor, on method, you just inject them when you create your objects. The benefits, you get a decoupled design, an easier testing, and a clear architecture. Okay, so then you will see where am I supposed to create those objects and do that nice dependency injection. And the answer is in the composition route. So that name, which is a bit verbose, is just to mention the place in the code where you're supposed to create your object and assemble them. It can be the entry point of your application or basically your test. So the first method you can use to do that is the pure dependency injection, which is just pure Python, and it's very simple to do, but there is a bit of challenge coming with that solution. So let's meet Handless, and just another dependency injection container. The idea is that it is fully typed, it's more flexible, you can manage the lifetime, the context, and lazy instantiation of your object, and cherry on the cake, there is an auto-while system. The only downside of that is, of course, as you can see, it can make your code a bit more complex to get when you have bigger applications. So a couple of examples, you can register using that library a value, which you will get back with the container when you get it afterwards. You can also register factories to generate your objects whenever you need them. You have the ability to register types or alias directly. The idea is that when you will resolve the type, it will actually resolve the alias you've registered. And you can also do nested injection. In that example, if you need to have access to another dependencies to create your one, you can access it through the parameter of the factory function. And the nice thing, you get auto-writing. So the idea is that the container will have a look at your constructor dependencies using type annotations and will automatically inject the required dependency through the container itself. And it can also manage lifetime. So if you want singleton, you will get a single instance of a value for the whole lifetime of the container. If you want a contextual dependency, you can get one per context. And finally, if you want a new instance of your object each time you call the result function, you can have a transient lifetime. It also handles context manager for you. So if the object you're returning with your factories contain a enter or exit function, it will be handled automatically by the container, which will do the cleanup for you. And there might be a much more coming in the future. So have a look at the documentation and just stay tuned for the rest. Thank you very much for your attention.
Thank you for the wonderful talk. Now we have Deborah Danjuma talking about Python and swimming robots. Can we have a round of applause?
Hello, hi. I'm Deborah Danjuma. I love robots, and that's why I'm a student. I'm a master's student currently studying robotics engineering at this university here, University of Girona. It's in Girona, in Spain, if you're wondering. And I study IFROS, which is this little icon over there. It means Intelligent Field Robotic Systems, which is basically, I play with field robots, basically, in a nutshell. I use Python and C++ for robotics, and it's my first time here, and it's my first lightning talk, sponsored by over there. And sadly, I don't have a cat to show you guys, maybe next time. This talk is about Python and swimming robots. Unfortunately, the robot is not this one at the beach. No, that's not the robot I'm going to be talking about. This is the robot I'm talking about. It's a robot I just built about me and my team over the past 4 to 5 months, and it's called the Mini Girona team. And as you probably expect, the name of the robot is called the Mini Girona. This looks a bit more cartoonish, so let's bring it to real life, okay? So this is the Mini Girona in the lab swimming. If you're wondering, if you're curious like I am, the Mini Girona has a Wi-Fi, it has cameras right there, an arm, it has lights, thrusters, and a sonar, which is essentially an underwater LiDAR, but it uses sound instead of laser, like in a nutshell. If for the academic guys here, if you're really curious about the technical details, you could just take a picture and check it out. Okay, so, but this conference is about software, not the hardware. Like, it's boring. So basically, the Mini Girona runs on ROS, not Rust, ROS. It's called Robot Operating System, and it's basically the foundation, like the software foundation on which the Mini Girona can do cool things, like right here, where the Mini Girona is exploring the pool at the lab at my university. It's a really cool, nice pool, and it's just swimming around. The thing is, ROS is written primarily in C++. So basically, and we all agree, hopefully, that C++ is a bit more tedious and is less pretty than Python. So some nice people like you in the crowd made Python bindings so that people like me and my team can do cool things with the Mini Girona in Python. So we're able to do cool things like localizing the robot, so the robot has an estimate of where it is in the world, and we can detect objects with the robot using the YOLO model, which is written in Python, and it just makes our life a lot more easier. And this helps us to do amazing tasks like rotating a valve underwater, or detecting a structure underwater with very, very shitty humidity. And this is really nice. And that's it. Thank you for listening. Big shout out to my team. And stalk me on LinkedIn. Thank you.
Thanks a lot for that. The next session is by Matthieu Amiguet from Switzerland to Europython Prague 2025 by e-bike and back. Welcome.
Thank you. So I won't be talking about software this time. To go to a conference like Europython, you can take a plane, you can take a train, or you can take your time. To come here from Switzerland, we decided to travel by e-bike. That's about 900 kilometers to come here, and as much to go back. Admittedly, our e-bikes are slightly non-standard. I don't have cat pictures in my talk, but that's almost as good. The first one is a tandem with a pilot in the rear, a passenger in the front in recumbent position. It has 2 motors to avoid overheating, even the Swiss mountains, you know. It has a custom battery holding 1.8 kilowatt hours in high-power cells in a 3D printed case carefully tailored to fit exactly in the frame. And when coming, we were using about 16 watt-hours per kilometer, which provides an autonomy over 100 kilometers. Incidentally, this means that it consumes an energy equivalent to 0.16 liters of fuel per 100 kilometers. The other bike is what we call a velomobile, which is basically a bike with 3 wheels and a fairing. It also has a solar roof and features the same battery as the tandem. So we can switch also if one has more energy than the other. With so many engineers in the room, I think I can speak about the sources of energy for this velomobile. It uses about 10 watt-hours per kilometers of total energy for going. From this, when coming here, about 35% was provided by the solar panel, 15% by the human riding it. We're not athletes, we are just normal people. 10% was provided by regenerative braking, that is pushing back energy into the battery when braking. And the remaining 40% was from a wall socket. That means that the net consumption was about 4 watt-hours per kilometer. That's about 200 times less than the 7-seat Alhambra of my neighbor, and only 40 times less than the Tesla of my other neighbor. So that with the same amount of energy, my first neighbor would have driven less than 5 kilometers, and my second neighbor, a very impressive 38 kilometers. So riding an e-bike is fun, it's good for your health, it's good for the planet, and it's also very social, especially if you travel with unusual bikes as ours. It's common that people come and ask questions when we stop, or even when we are riding. You know, a car coming next to you and opening the window and, oh, what is this? Oh, that's nice. What's the autonomy of this thing? It's sometimes a little bit surprising, but it happens quite often. If you want to know more, you can follow this link. On that page, you can also support us if you want. And if you want to see the bikes in real life, they are in the front of this very building right now. So just go and have a look after the closing session. Thank you very much.
Thank you very much for that electric talk. Now we have Sheena talking about Python in Africa. Can we have a huge round of applause for her?
Thank you, Doreen. Right, so the Burmese python is an invasive species in Africa. So I have a question for you. Who's been to Africa? Yeah? Okay, cool. Who wants to go to Africa? All right, so it's a lot of hands. Why? Why do you want to go to Africa? Is it, no, really, like, is it because of the landscape? Is it because of the people? Is it the mountains? Is it the forests? Is it the deserts? There's a lot of different reasons. I have a reason why you might want to go to Africa, and that's for the python. Africa is a very, very big place, and it is full of python communities. I'm from Africa. It might not be immediately obvious, but I am an African. My family's been in South Africa for many, many generations, and there are a lot of Africans here in this room. Can I get some hands again? Yes, yes, yes. All right, so we came a long way. Say hello. Ask us about what we're doing back home. So again, Africa is a very big place, and I've been to a bunch of different African conferences, and I would like to invite you to come and explore them as well. So PyCon South Africa, ZA for some reason, is my home conference, and it's changed a lot in my life, and it's fantastic. PyCon Namibia is also really, really amazing. Namibia is full of rolling desert sands. It's freaking beautiful in a very harsh kind of way. PyCon Namibia is a very impactful conference. We go there to share skills. We teach while we are there. DjangoCon Africa is also really incredible. The first one ever happened a couple of years ago. The next one is happening now. It's happening in August in Arusha, which is very, very close to Mount Kilimanjaro. So if that's your jam, that's worthwhile. And PyCon Africa, that's happening in South Africa this year. So those are the ones that I know about offhand, and those are the ones that I have been to or am involved in. But again, Africa's great. It's really big. So there's a lot going on. And if you've ever been tempted to go to Africa as a tourist, visit a conference instead. It's a lot, the experience is a lot more meaningful because you get to interact with the locals, actually make some friends, and tour in a useful way. So my experience is that the African communities are solid, passionate, skilled people. I think a lot of people have certain assumptions about what goes on in Africa and how things work. There are big problems, but there's big brains and big hearts and big solutions. It's a growing place. The community is growing in many, many ways. A lot of people are quite young, and that's fantastic. It's just full of potential. And it's resource constrained in many ways. And that's not necessarily a bad thing. It brings people closer together. It means that people have to rely on one another, and so social ties are stronger. And that's really quite amazing sometimes. So yeah, I invite you to get involved, come and visit, stay in the loop, follow along on various social media things. So I post about stuff, follow PyCon Africa, we repost stuff, go to a local conference, make some friends. And if you can't get there physically, then watch the talks online. No, PyCon Africa is streaming online. Other conferences might as well. If you can take part, even online, then it's pretty cool. There are some people who, yeah, we should shine a light on a lot of what's happening there. So, yeah, that's it. Thank you.
Thanks a lot, Sheena. The next one on stage is Takanori Suzuki. He's going to teach us to talk about how we can learn Japanese using Python. A round of applause for him, please.
Oh, wait a moment. Wait a mirroring. Wait, please. Huh? I checked the display setting about the mirroring. Where it's? Okay. Well, up.
No, left maybe. One of the sides down.
Where it's this?
Go down.
Or what? Where?
Can I try?
Yeah, sure.
What side is it?
What I wanna mirror. Oh. Hey. Sorry. I'm so confusing.
You can go by with the mouse over there. You can see on your desktop, so you can drag it over there.
I can't see.
Can I try one thing?
Sorry.
Which direction is it?
Over there.
Is it up? Where's the cursor?
Sorry. Wait a moment. I'm going.
Mirror?
Mirror is good for me.
That's it.
Okay.
Just a full screen.
Yes. So confusing because I heard my right-hand clock before 2 minutes. Yeah. This slide is a 2024 US version, but I told about it. The PyCon JP 2025 in Hiroshima, Japan, okay? And end of September, please come, because I came here, okay? I have a question. Have you learned Japanese before? 5% maybe. Are you interested in Japanese language? Oh, thank you, 80% maybe. And oh, yeah. I'm interested in Japanese. Okay, Japanese language is difficult, I know. 3 types of characters and no space between words and multiple readings of kanji. I described a difficult point. 3 types of characters and kanji. Japanese have a hiragana and katakana and kanji characters. This emoji is a snake and heavy. It's the same word and different characters. Difficult. Next. No space between words. Japanese language is no space in between. This word is a sumomo momo momo no uchi is a correct sentence. Sumomo momo momo no uchi. Can you understand? No? Okay. It's difficult. And sumomo momo no uchi is a correct sentence. And multiple readings of kanji. Kanji in Japan, kanji character have several readings. Japanese style readings and Chinese style readings. This kanji character means day and sun, but Japanese style reading is nichi or ka. Nichi or he, and the Chinese style reading is jitsu or ka. For example, this idiom is a Sunday is the same kanji word, but reading is a nichiyobi, different reading. And this idiom is a previous day, is a zenjitsu. First one is a Japanese style, and the second one is a Chinese style. Difficult. And some combination idiom is but different readings. This kanji idiom is a first day or one day. One day. Oh, you understand. Oh, makes sense. But this word is a first day, day one, and this word is a January 1st. First one is a ichi nichi me. Is a Japanese style reading, and the next one is a 1月1日 is a Chinese style reading. Oh, sorry. Sorry. What? Oh my gosh. Resume. Okay. So difficult. At last, special readings of some kanji idioms. This word is today, nowadays, and yesterday, past day, and tomorrow is the next day. But reading is kyo, kino, asu. No rule. Oh my gosh. But you can learn Japanese with Python. No space in between words. Monochi. I use a Japanese morphological analyzer, SudachiPy and SudachiDicto. This is a dictionary. And word segmentation, make a tokenizer, and get a token, and get some words. Monochi. Correct. Perfect. Next problem, and multiple readings of kanji. This sentence is today is January 1st and Sunday. And the same kanji but different readings in this sentence. How to read? Okay, I use a morphological analyzer and get the token and get the reading form. Reading form is a katakana reading style information. And the part of speech is a noun or something, verb. And get the reading is a token, get the token and the token reading form. As a result, 今日は1月1日で日曜日 in katakana words. And can't read katakana you, I know. I can make combat Japanese characters with JA-comb. JA-comb convert katakana to hiragana or katakana to alphabetical style, Romaji. You can get 今日は1月1日で日曜日. You can read. Okay, skip the audio information. I make a sample application. If you're interested, please get this code and run the stream. Thank you. See you in Japan. Okay, thank you.
Thank you very much for that wonderful talk. Now we have Moses with a very musical surprise. A big round of applause for him.
The audio, yeah. So this is a talk about stress levels, managing stress levels. So we check the video, we have video. We check the sound. Sound, we have USB sound. We check MIDI frequencies. MIDI frequencies are in place. Then I'm going to talk about Foxdot. Foxdot is a music synthesizer, well, is a Python wrapper around Super Collider, which is a music synthesizer. If we run Super Collider and use the Foxdot module, it's running. I had problems in the past with this. If you want to see it, look for the previous lightning talks on previous years. Here on my terminal, I can run Foxdot, and it didn't break this time. I'm not going to update Foxdot right before my presentation. And I will open this. This is just simple code. I just want to show you how it looks like. So this is Python syntax, and this is just some settings. Let me put something to play and to see if we have. So basically, I'm hitting Command Enter to execute, and now you can hear it. So this is Foxdot talking to Super Collider to produce these sounds. And I have here, let me zoom in. So B1 is my player, base 1, and this is, I'm assigning this player to play this sound, this instrument, like a function, and the parameters is what's gonna play. And the play is a sample. So each character is a different sound. So we can have it like this. You can assign variables, so you hear now that it's changing the note. And you can layer more and more instruments. This is not my main thing that I want to show that you can do with Python, but so I'll rush through this a bit just to show the capabilities of Foxdot. It is used on things called Algorave, where people do live coding and they produce music on the spot. And you can use decorators to schedule a function to the next time, so you don't have to be like very precise on where to start the sound. Some changing of the beat. And I think also you can use clock to schedule functions for the future. I have some lambdas here. They make this nice effect that you'll see now. Okay, I'll stop this part here because I want to see, thank you. So today, I prepared this. I spent the whole afternoon stressing about this code. So basically, let me execute here. I'm importing chords from the library, so I don't have to define them myself. I can just use the numbers. So down here, you can see like second chord with a 7th note, so on. And each one of these in this list is the chords that are going to play. I have this. This, yes, it's for you to help me. Yes, but let's hold it for now a bit. We'll get there, we'll get there. And then, yes, I'm going to play this, yes. And this sounds like this. And this is a very famous song among Pythonistas. It's been performed at almost basically every Python conference I've attended in the Czech Republic. There's a group of people that always gets together and want to play this song. Do I have? Yes, I do have this. So I also have another task for you, because we are going to multitask together. Can I ask for a volunteer to pass on the, yes, yes. You will help me. You just have to skip the lyrics while we sing. And no, yeah, no, but we're going to start. I need to get ready.
I just skipped the lyrics, right?
Yeah. Let's see how it goes.
You got this.
This. Curse. And when you chew in your life was great till Grum. Could Grandpa give a whistle? Is it? Oh, no. Yeah. Always look on the bright side of life. Side of life. Always look on the bright side of life. For life is absurd and death is final world. You must always face it in the curtain. You can keep singing. And I would like to invite to the stage. I would like to invite to the stage my companion musicians there among the crowd for us to jam for a minute. Yes? Okay. Thank you. That's it. Rodrigo said no. We continue. Yeah.
If you play instruments, find us.
Yes. You want to announce the pie. What's the name? Did we find a name for it? We are on Discord.
That was wonderful. A round of applause for our speakers once again. So we've reached the end of the lightning talk.